Hello, in this video we're going to take a look at how to build an amortization schedule or an amortization table in a spreadsheet. So what I have here is Google Sheets open, and I've done a little bit of setup for us. I'll talk about what's in all of these cells here coming up, but we're basically looking at example 5 from the slides, which says let's take a $600,000 loan that's charging 3.9% annual interest, and the loan lasts for 30 years. So it's like a home mortgage. So notice what we have here in the spreadsheet. We have the rate of return up here in cell B1. We've computed the payment. We'll get to this a little bit later, but let's just, for now, pretend that this has been computed somehow. And then we've got these different columns for what the payment is each month, the interest that we pay each month, the principal that we pay down the loan by, the actual month number. I've moved this column here over next to the balance, and we'll see why here in a minute when we go to draw a graph. And then we have the new balance at the end of that month. So month 0 is sort of the start of the loan. That's $600,000. Okay, so let's take a look at how we've built this, this spreadsheet. Look over here at cell A6. Notice that what I've done is, we double click this, you can see that this is equal to $B, $2. The dollar signs create what's called a fixed or a locked reference, an absolute reference, which means if I were to copy this formula down or over in some way, it is not going to allow the column B to change. It's going to lock B, column B, and it's not going to allow the row to change. It's going to lock it in row 2, which essentially means it's always going to grab that as the payment amount. So if I take a look at what's happening here in each of these cells, this is always B2. This one here is always B2. So if I copy this formula down by holding the mouse button down and dragging down a few rows, it's always going to copy that exact formula as an absolute reference. Okay, so let me go ahead and undo that real quickly, and let's go to the next column, which is the interest column here. The interest calculation, if I double click, you'll see what's happening, is it's taking the annual rate, which is in B1. Again, that's locked because that rate never changes, and we always want to grab that rate in B1 if we were to copy the formula down. It's dividing by 12, so this is like the R over K. And then it's multiplying by whatever's in E5, which is over here. It's the balance. So essentially what it's doing is it's taking the monthly interest rate, which is B1 over 12, and it's multiplying that by the loan amount in E5. Notice E5 has no dollar signs on it, which means it's called a relative reference. So if I were to copy that formula down like this by clicking and dragging this little handle down, what it does is it copies in each row below it a new formula. But because I've locked B1, it doesn't allow the rate of return to change. And because I have not locked what's in E6, instead of going up and multiplying by the $600,000, it's going to multiply by the row that's below that. So that's what we mean by a relative reference. You can see here, if I double click on this one, it's locking B1, but now it's going up one row and then over 3 columns to get to this number to compute the interest for that particular month. All right, now let's go to the principal column here in column C. All right, so this first cell in cell C6, the formula looks like this. It's 2 numbers, both relative references. It says take whatever's in A6, so 2 columns to the left, take that number, which is the payment, and subtract from it the column directly to the left of column C, which is how much interest we're paying that month. So the payment is made up of 2 pieces, the interest we pay to the bank and the principal that we pay down on the loan. So the principal that we pay down on the loan is simply the difference between those 2 numbers. And you can see here, each one of these is again a set of relative references, 2 columns to the left A7 minus one column to the left, B7. And down here, again, two columns to the left is A9 minus one column to the left, B9. So that's going to continue to be copied down here in a moment. For the month, this one's an easy formula. You can see that each formula is simply the cell above it plus 1. So we're just adding 1 to the total months. And again, D7 is a relative reference that has no dollar signs. So it's always going to take the cell directly above it and then add 1 to it. And then finally, the new balance. We started with 600,000. This is the first cell right here in E6 where the number is computed. The new balance, you can see, is E5, the cell right above it in orange, minus the amount of principal that was paid down in that month's payment. So that is minus C6, two cells to the left. Each one of these is going to behave the same exact way. Take the cell above it, the previous month's balance, minus the principal, two cells over, that was paid down in that month. So each of these is going to look exactly the same. Right? E8, take the balance the month before, subtract off the principal paid off in that month, two cells to the left. So I have all of these formulas now built up across these 5 columns. And so what I'm going to do now is copy all of these down. So I'm going to click and hold all the way across these 5 columns, saying I want to copy down all of these formulas together. And I'm going to drag this handle down by clicking, holding, and then coming down a few rows. And notice everything automatically computes for me, right? So if I go all the way down to 360 months, let's go ahead and do that. Just be patient as it scrolls down. I've put a marker in here so I know when to stop. Let's give that a minute to go. There's the marker. So I want to hold off right there. Did a little pre-planning here, and I'm still holding my mouse down. I've dragged that handle all the way down here, and when I release the mouse button, watch what happens. I'm down to 360 months. I can see here that the payment has stayed fixed because it is always going up and getting B2, right? The interest paid is always going to get the rate of return, but it's multiplying by the previous month's balance to compute the interest paid in the very last month. Right? And all of the formulas behave the same way so that we get to a 0 balance at the end of 360 months of payments. I'm going to scroll back up here. We can see how that behaves in the start of the table as well. So that's how you can build one of these. And what's really nice is you can now say, let's take the month and the balance, and let's select all of the data in those 2 columns. And what we have here is the column on the left is like the X variable, and the column on the right is going to be like the Y variable. And we're going to create a graph of all of that data. So I clicked and dragged all the way down. I can scroll all the way back up so you can see it starts here with the headers, and then I'm going to insert a chart. So select that command, and here is my chart. Let's make that a little bit bigger. And if I want to, right now it's a scatter chart, but I can also make it a line chart to make it a little bit more smooth. But what you can see here is that at time 0, month 0, the balance is up here at 600,000. And then over time, by the time it gets to month 360, the balance is at $0. So this gives us a snapshot of how the balance changes over time. So you might want to take this particular spreadsheet, fiddle with it. Notice up here, the rate is just entered as 3.9%. The payment uses the command called the PMT command. And so the PMT command, which we'll cover in another video, will actually compute what the loan payment will be if you give it all of the relevant information. So that's for another video, but what this all allows us to do is things like this. We can say if the rate changes to 5%, right, then the entire table, including the interest per month, the principal, the balance, will all update, the graph will update, and everything will be automatically updated for us. You can even change things like the balance of the loan. So if I only borrow $400,000, right, notice that the balance here in the graph, when I hit enter, is going to change. Now it starts at 400,000, but still goes to 360 payments, goes to a balance of 0 because I haven't changed the length of the loan. So a spreadsheet is going to allow us to do all sorts of really interesting what-if kinds of calculations to compute what each month's interest, principal, and balance looks like as you make your way through the loan.